has introduced some of this. So I'll just be going over a very brief system overview of the system that we actually have at the ALCF, how to gain account access, how to log in, how to set up your Conda environment, and the workflow for compiling and running simple samples. We saw a chart like this in the previous presentation. At ALCF, we have a single GroqRack. It has 9 servers in it, 8 cards per node, and one chip per card. There's also a controller that is in the background. First thing you have to do is request an ALCF account if you don't already have one. A lot of people on the call on the Zoom will have one already, but if you don't have one, you'll need to request one, and you'll need an active project account. So the link there is accounts.alcf.alnet.gov. You'll have to open the PowerPoint to expand it, I guess. And that's the help email. Once you have that, you need to join a project. You need to join the Groq training project. And once you've joined the Groq training project, then you want to make sure that you actually have access. The menus will change on that page, and you'll be able to request and view systems, and you want to make sure that Groq is in the list of systems that you have access to. Once you have access and all of the access control stuff has filtered through the system, you should be able to log in. We have 2 login nodes. Groq login 01.ai.alcf.al.gov, Groq login 02, and those are where the access control is. And to access those, you will need a mobile passcode as your password. From the login node, then you can log into any one of the 9 GroqRack nodes. In this case, it's showing logging into the first GroqRack node. Once you're logged in, the first thing you'll need to do in this environment is set up Conda. And I think probably most people are familiar with how to do this, but here are the instructions. I noticed earlier that if you copy and paste from PowerPoint, it won't necessarily work, but so you might have to retype a few things. But basically, you get Conda and you run the Conda installer, and you answer yes to everything unless you prefer to do otherwise. Then you need to create a GroqFlow Conda environment. We're assuming that you work with the GroqFlow samples. GroqFlow is a toolkit that helps you create applications in Groq, including a bunch of samples and sample code. So this is, and then once you've done that, you also need to clone the GroqFlow repository and make sure that you have the GroqFlow Conda environment activated. Once you've done all, you need to actually install the packages for GroqFlow, and you do that by changing to the clone of GroqFlow that you just checked out. And there's some extra steps in here that may go away with a future version. This was to correct some problems with the install, but this procedure should work. And we've documented the procedure along with other aspects of Groq at our ALCF documentation website. The link is up top, docs.alcf.handle.gov, etc. And this takes about, I don't know, 3 or 4 minutes to do from scratch. And you only need to do that once per release. So the workflow at ALCF, we do have a PBS workload manager and job scheduler. The Groq flow framework combines both compilation and execution. And compiles are cached, so the compilation only happens once until you change the model. You can make minor changes to the programs without forcing a recompilation, as long as you don't change the model. Compile artifacts are in the cachers, and some of them will tell you things like how many chips are being used, how many chips the compiler decided to use. These steps can also be done manually, so you'll have to ask us for the documentation on that. But basically, the compile workflow consists of the following steps that are all automated through the Groq flow, GroqRack. Onyx compiling, exporting to Onyx. I believe they're making this, Groq is making that step go away. Converting to FP16, compiling and assembling. So there's 2 ways to use PBS. One is to create a script and to launch a job using PBS. If you do that, you'll have to start up Conda in your script. So this is basically copied from your bash RC up to this point, and then from here are the steps that you would actually need to run. And let's see. You can also, and you'll probably end up doing this, run samples no, excuse me. This is batch mode. Yeah, so this is how you run the batch process. You're doing Q sub, specifying the number of Groq cards, specifying the script, and the output goes into files of this form here. Interactive mode is what I think people will end up mostly using. You could specify a full day of wall time and how many cards you need. Once you're in a interactive mode session, you'll need to activate Groq flow in it. And here's an example: you activate Groq flow, change to a particular sample directory, make sure the requirements are installed, and compile and run the sample. The number of chips that are needed is determined during the compile phase, although you can offer hints. The value can be found by looking in one of the compile artifact files in the cache directory. So here's an example for a sample that was run above, and the compiler decided that it needed one chip. Utility commands consist of the QStat. The PBS utility commands are QStat, QDelete for deleting a job, and QHold if you want to hold a job. Mainly QStat and QDelete and QSub. We have the GroqFlow repo. You can go up one and see other things that Groq has at github.com/Groq. GroqFlow is just one of their repos. The ALCF AI Testbed user guide, I gave a link to that earlier as well. And there is some documentation, so white paper level mostly, on the Groq site. And that's it. So now I'm going to show some live demo. The first thing, this is my laptop, and I'm going to SSH to a login node. I've already have several other sessions open, so it's not going to ask for the password. It's just going to log straight in. The password would be the one that you get from your mobile pass application on your device, where you put your authentication device application. Once you've done that, you can SSH to any of the nodes. You can SSH to 01. In this case, I'm SSHing to 09. And the usual warnings. The first thing to do is to get the GroqFlow code. So I'm going to delete my GroqFlow directory and reclone it. It's a relatively small project, so it clones quite quickly. I've already installed Conda on this machine. As you can see, I have Conda installed. I'm not going to redo that because it takes a little bit, and I also don't want to blow out my existing Conda environments. So I'm going to make a new Conda environment. I'm going to call it GroqFlow test. We're specifying what version of Python to use. This is the current one on the system. This is the current one on the system. And we're creating a Conda environment with that Python version and then activating it. And here you go. So let me briefly run over what's in the GroqFlow environment. You have a README, you have a docs directory that has things like installing GroqFlow and the user guide. You have examples. And there are examples for PyTorch. You'll note there's Keras support, so there is some TensorFlow support. And if you have an Linux model, there's ways to use that directly. And the GroqFlow and the demo helpers are directories for the actual GroqFlow Python packages. And the proof points, there are examples for PyTorch. You'll note there's Keras support, so there is some TensorFlow support. And if you have an Linux model, there's ways to use that directly. And the GroqFlow and the demo helpers are directories for the actual GroqFlow Python packages. And the proof points are where most of the samples are, although there are some samples in for instance, PyTorch has a Hello World sample that's useful. So in this example, it's defining a model, it's making a model, and then it's running this Groqit right here, which is the thing that takes a PyTorch model and converts it, or takes a model and converts it to a Groq model. And then it runs that model. Basically, here it's just running it with one set of inputs. The main set of samples are in proof points. They're divided into computer vision, natural language processing, and a single speech sample. So next step, I'm going to install GroqFlow. And I recall that this step takes about 130 seconds. So again, this is a step that you only need to do once per release. There's also another package that you have to install, the demo helpers. This is a bit quicker. So now I'm going to try running a sample. I'm going to run a computer vision sample, data efficient image transformer. It's a 2021 paper, I believe. And most of the samples in the proof points are of this style. First thing they do is they get a model, an external model, and load it. In this case, it's using transformers, and in some cases it uses Hugging Face. Then you need to create input, dummy inputs for this. You can also basically instrument your main training loop if you're worried about getting the shapes wrong. Then you're calling the GroqRack with the PyTorch model in this case, and the dummy inputs. And this is the compile step. This takes, if it hasn't been cached for this model, I believe it takes about 3 minutes. Hopefully, I think it's cached at this point. And then all of the samples basically run both the GroqRack model and the PyTorch model in CPU mode and compare performance and accuracy with each other. And the code is relatively easy to modify if you feel like you want to compare with a GPU or such. You can do that. I've done that at least. There's no GPUs on these systems. You have to do it on another system, but you can modify the code. So then running the sample is simply a matter of making sure that your Kana environment is activated and running the sample like so. And all the samples are run this way. They all use data sets that are pre-built or pre-available. So there's no data prep for these samples. The model was found in the cache, so it didn't spend 3 minutes rebuilding it. The inference on Rock chip is quick enough that you don't even notice it most of the time for these relatively small data sets. And it's now running in CPU mode. This will take, well, you can see how long it'll take. I'm going to let it complete so that it shows the results when it's done. And all of these samples are using a batch size of 1, basically, inference batch size. They might not utilize the hardware as much as a larger batch size would. We have some examples available if you want to use larger batch sizes and do batch mode for inference rather than a low latency inference.
Yeah, so while it's happening, so I'd like to remind that so the slides that Bill is using, they're also uploaded on the page. I've put a link on the chat window. Feel free to use that slide deck and just try log into the system and follow this tutorial. Thank you.
And there are other vision models. Most of the vision models and the samples are are more standard like MobileNet or ResNet. This one is a transformer-based model. So when you run a sample, you get a table like this that hopefully tells you that it's a lot faster than the CPU and things like latency. So that's it for a demo. So I think I'm done.